We heard some wonderful discussions earlier about the importance of geospatial data, so roads, where the population is, topography and so on. We also take into account vegetation, soil moisture. Some of these are more static, but increased sensing will be important in terms of giving us more timely information and accurate information around that data. Some of that data is obviously from the social side, being able to harvest information from social computing site systems like Twitter and so on, and also from people just using their mobile phones increasingly as sensors. So we take that data and we then have a set of models that live on this platform. So for example, we have a set of weather observations, but we can take technology as we've developed in IBM Research, some very high resolution weather forecasting technology, and run a very, very accurate and high resolution weather forecast. So we're not talking about sort of predicting at the accuracy of sort of 10 kilometres. We can deal with a weather forecast that can get down to half kilometre sort of grid resolution, which is really important in terms of how that weather can force and change the behaviour of a fire. So we take the weather forecast, we then have the ability in the platform to do a fire risk assessment. So that's taking the topography, the soil moisture, the vegetation, and actually identifying where a fire is more likely to occur. Where is the danger if a fire was to start, and model the intensity of fire. Now, we haven't worked out where those fires are going to be yet. We're just working out where the risk of fire might be in a particular area. We take that, we integrate that data with the fire spread prediction model. In this case, we're taking a model that's developed by the University of Melbourne called Phoenix. This has actually been applied in practice operationally in the Fire Service Commission and State Control Centre. And we provide the weather information, these high-resolution weather forecasts, fire risk. We identify where potential fires may start, and then we model the fire spread. And this gives us a view over time and space as to where a fire might move or propagate throughout the particular region. And then, of course, one of the key questions that we're always trying to ask, and this is, the Fire Service Commission working with a sort of collaborators is really important, is they want to understand where are people going to be at risk? Where do I need to put resources? Someone's just, phone has gone off.
Extreme fire conditions, and we'll just need to use the ADMP for briefly. Okay, so Dave, currently the situation is we're at 38 degrees with 35% humidity. Tomorrow's forecast is that we're going to reach 40 degrees with strong gale force northwesterly winds, and on Thursday we'll be having 42 degrees plus. Once again, strong gale force northwesterly winds with a southwesterly change later in the day. Now these are exactly the same conditions that we had on Black Saturday. So our mission will be to plan a response to this weather condition. So, Glenn, do you have your technical guy who can drive ADMP for us, please? So just while Sky's coming up, Dave, from your experience in Black Saturday, what are the things we're trying to avoid?
I do have a couple of slides here, and the first slide that you can see is obviously is a photograph from Black Saturday of a number of burnt cars. Unfortunately, these were people who tried to evacuate and left it too late, and they are real photographs. And of course, the major aim of any of the emergency services is the protection of life, and we cannot and should not ever let that happen again. Some hard statistics on Black Saturday. Let alone did 173 people die, 414 were injured, and nearly 1,500 buildings damaged. The fire extents, and that's them. As you can see from that, there were 9,600 fire-affected addresses, and that was basically because it burnt close to the Melbourne metropolitan urban fringe, and they are the fire extents up there. And I think somebody made an analogy saying that if you looked at a map from London to Portsmouth, that's about how far the fire's burnt. So they would have probably burned out an area, if not as big as Manhattan, maybe bigger.
Okay,
And 12 months later, we weren't burning, we were flooding, and that was quite huge. And then to complicate matters, just last year, in the west of the state we had floods, and in the east of the states we had bush or forest fires.
Okay, Guy, yeah, could you just operate ADMP for us? I just want to understand the risk to the community with the fire danger that we've got over the next 3 days.
Sure thing.
Yeah. One of the first things I really want to know is the threat across the different fire routes. So can you explain that to me, please?
Sure. I brought the tool up, and what you see now is, again, what you received from the Bureau of Meteorology. This is the state of Victoria, Central District, that includes Melbourne and our Dandenong ranges, is in extreme danger rating, and as you've requested, I'll look closely at the Dandenongs and focus our assessment for that particular region. Give that assessment a name. And you've requested that we identify the threat to civilians as a cause of the fire. So now the assessment simulation that Glenn just mentioned runs. We're taking, again, weather forecast, detailed weather forecast, localized weather forecast to produce very specific, localized and short-term forecasts of winds and temperature. And then we take that and are able, based on the topography, bringing in topography, ground, vegetation, and temperature, moisture, and are able to assess where fire most likely can occur. So we select a few sample, a few ignition points to cover this entire area, and we run for each of these potential fires a simulation, where as Glenn mentioned before, we're using another tool that's come from the University of Melbourne, where over time you'll see how fire spreads, where at every time, at point in time, where it covers, and also the intensity of that fire. Now that we know where the fire will occur over time, we can start running the simulations for the evacuation and understand where people would move to, when they move. Some of them start moving just because they can see the fire, others react to the warnings. Depends also how many people there are currently. Is it school day, is it during the day, and so forth. So one of the conclusions come up is every period of time where people are equal by a single car, and we have a very good understanding how many people are in each neighborhood, for example, and as the fire moves in, we can compare the amount of people that are in that neighborhood, and we'll conclude then that those people are at risk. So risk, civilians at risk means that a person has not been able to evacuate before the fire reached their neighborhood. And I think the assessment is complete. Let me bring it up. As you can see, through all our fire ignition samples that we've conducted, all of these simulations resulted in the following yellow neighborhoods, in color in yellow, to represent the number of people that have not been able to evacuate from those neighborhoods in time before the fire reached that area. We also included the fire agencies, fire services, and some assets deployed, so you can make your decisions on how to go about this current situation.
Okay. That's great, Guy. Can we break that up so I can understand the risk to the communities a bit more? Or can you show me the map, which communities are at risk?
Yep. So these are the following neighborhoods that cover the Dandenong regions. Yeah.
Okay, and what would be the worst case scenario that we might be facing over the next 3 days?
Okay, sure. So what we can do is actually we ran each of these fires separately and can simulate them, and therefore I can identify the worst case scenario. If I pull down these fires, these are the fires that we have simulated. What you see right now is the fire risk assessment. These are the hot spots that we have identified based on the weather, based on the vegetation. current conditions where most likely the fire could ignite. And then, as I said before, we sampled a few ignition points to get a good coverage of this entire area. And you can see here that this particular fire is probably the worst case scenario. And it could ignite around the township of Kalorama. Yeah, so that would be the worst case scenario.
Okay, so Guy, are you able to run the simulation so I can see what would happen up to Kalorama?
Sure. So let me bring that fire up. And again, we have sampled this fire to ignite at around 10:30 a.m. out of Kalorama. And we can see that over a period of 12 hours, it starts moving southwards towards another township called Mombo. And if I overlay that with those neighborhoods that you just asked me to do, is we can see that these particular neighborhoods that are really colored in red over time will most likely be impacted by the fire, and we'd expect people to evacuate from those neighborhoods.
So with the evacuation, where's our greatest risk for people not being able to get out in time? Can you show me that?
Yes. Then I can show you. As you can see, the assessment based on today's time and the tourists that are coming in, and maybe businesses or people moving in for their own businesses, we are predicting that there will be around 7,500 people around this area, and those are the people that we like to see them evacuate. And if I run that together, as the evacuation starts moving, you'll see the colors start to lighten up because people have moved, so the number of people decreases. We stop the counting once the fire reaches that region, and therefore we have the number of risk civilians at risk. Let me just run it again, and now you can see start to light up. Red fire starts to reach those regions, and over a few hours, the outcome is that we have around 1,000 people that have not been evacuated as fire progressed.
Okay, could you just run that simulation for me again? And Dave, I'll just have a look at that up that north and the eastern side of the area. I'm pretty concerned about those two areas. Okay, that's right. What do you think the key considerations are, Dave, for this fire over the next few days?
In planning a response to a fire such as that, some of the key considerations will be, number one will be emergency alerting to the various communities that may be affected. And for those who don't know, currently throughout Australia we have access to both hardwired telephones and the mobile phones for sending out regional and area-based emergency alerts to warn people of impending danger, disasters or evacuations. So one of the key areas is getting those messages out as early as possible, getting those that can evacuate to evacuate, get out of danger basically. One of our other very large considerations are the vulnerable people in the area, people in nursing homes, childcare facilities, schools, hospitals if there are any. We will have to be looking at what sort of critical infrastructure which the community relies upon in those areas and how that may need to be protected, or if it's not protected, how do we provide alternatives? One of probably the most important considerations is we've also got to be careful, and this has been a very topical issue, of our own resources. Not being in a position to put them in harm's way, or actually catering for any changes in the weather or the fire behaviour that might occur. But the bottom line is, it's trying to make people, it's giving people enough information to make informed decisions, whether it be the community or the incident controllers.
Okay, thanks, Dave. Well, look, I think what we'll do is we'll get the emergency management team together. We'll meet in about 30 minutes. And Dave, can you make sure we've got the education and health at that meeting for the vulnerable people, and make sure we've got the media and corporate comms there so we can get the media message out for the community. Now, Guy, are you able to be back in about half an hour so you can run the simulation for the team again?
Yes, definitely. I mean, we have it stored here and can bring it up anytime we want.
Okay, so we'll meet back in 30 minutes. Thanks, man.